So just some fun factoring problems. For this first one, sort of nice to realize this. That is a perfect square trinomial, isn't it? So it's x plus 2 quantity squared minus y squared. Once you have that realization, then you can look at this new expression and realize it's of the form, it's kind of like a squared minus b squared, which we know factors to a minus b times a plus b. Well, if we look at this expression here, it looks like a is being replaced with x plus 2, and b is being replaced with y. So now we go. So it's going to be a, or x plus 2, minus b, or minus y, times x plus 2 plus y. And there's no like terms to combine there. Okay, let's look at another one. This question. So this one, we don't see any perfect square trinomials in it or anything like that. What I do notice is if I look at the first two terms, they have something in common. A squared, right? So if you factor out a squared, you realize, hey, wait, to get back this expression, I would need to have a minus 2. Okay. Now look at the last two terms. They have something in common also. They have a 3, so I'm going to factor out a 3. And when we do that, we're left with a minus 2. So if we look at this new expression, here's the first term and here's the second term. And those two terms have something in common. They have a minus 2 in common. So just like in this first part of the problem, I took out an a squared as a common factor, and I took out a 3 as a common factor. Now I'm going to look at this next step in the problem. I'm going to take this out as a common factor, a minus 2. So that's the part that might be new for some people, is having a binomial as a common factor. Okay. Sometimes some of you may have seen this before. It's called factoring by grouping. Okay. Then you ask yourself, what do I have to multiply a minus 2 by to get a squared a minus 2? Well, I have to multiply by a squared. And then what would I have to multiply a minus 2 by to get 3 times a minus 2? Well, plus 3. And there you go. That's it. That's your answer. All right. So this kind of looks like that factor by grouping problem we just did. On the first two terms, you can clearly see that a c squared comes out. You'd have d squared minus 25. Okay. On the second two terms, you may or may not know that 9 goes into 225 25 times, but it does. But clearly, if I factor out a positive 9, I'm going to get with negative d squared plus 25. That's not what I wanted. So factor out a negative 9 instead. And that's sort of the key step to realize. And then you can have d squared minus 25. And now you see you have that common binomial. So I'll say that this often happens in factor by grouping. Sometimes out of the second two terms, you might have to factor out a negative of the common factor that you see in order to get the binomials to match. It's just a common thing. And there's two more differences of two squares. Okay?